Hello, everyone. Welcome to our practice state to help us get ready for the quiz tomorrow. I hope you find this video helpful, but we're going to be going over several of the different concepts that we have done so far in Chapter 8 today, just to see if we can get ready for the quiz and hopefully generate some questions in the Zoom chat if you have them. All right, so we're going to go right back to the beginning. Back in the first part of Chapter 8, we kind of started with looking at polynomials and finding this kind of information about it. Like what are the zeros, what is the leading coefficient, the degree, the end behavior, and then ultimately drawing a quick sketch of the polynomial that is given to us. All right, so this polynomial is given to us in its factored form. Right, and we can tell that it's in factored form because of all the parentheses that are being multiplied. So each of these things, right, each of these parentheses that has an x in it, these are called linear factors. Okay, and we can go to those linear factors and say, okay, if we have x plus 1, one of the zeros must be -1, right? Because if I put a -1 in for x, I get -1 plus 1, which is 0. Well, we can do the same thing here. If I have x minus 1, then +1 must be a 0. And if I have x minus 2, then +2 must be a 0, because 2 minus 2 is 0. And then on the last one here, we're going to get -4 as one of our zeros, right? Because -4 plus 4 is 0. All right, so then the next thing they want to know is, what is the leading coefficient? Well, the leading coefficient is always the number out front of the parentheses, right? So this 5 that's sitting out front here, that is our leading coefficient. So we're going to say leading coefficient is 5, and really what we care about is the fact that this is positive, okay? We're going to use the leading coefficient in the degree to help us determine the end behavior, all right? So while we know the leading coefficient is 5, we're more concerned with the idea that it is a positive number, all right? Now the degree, okay? So the degree is equal to the number of linear factors that we have, right? And at face value, if we're looking at this, we're going to say, well, there's 1, 2, 3, 4 of those linear factors, but these linear factors have exponents, right? So when we look at these exponents, these indicate that there are multiples of the same linear factor, right? So this x plus 1, there's actually 2 of them, right? Because we have an exponent of 2. That means x plus 1 times x plus 1. So there's 2, 3, 4, 5, 6, 7, 8, 9. There's actually 9 linear factors here, so the degree is 9, and what we really care about is the fact that that is odd, okay? So we have a positive odd polynomial, and when we have a positive leading coefficient and an odd degree, we know the end behavior is going to be down on the left and up on the right. Okay, so that means as I head off to the left, right, if I'm looking at my graph, as I go off in this direction, my polynomial is going to be going this direction. It's going to be going down, right? But as I go off to the right, it's going to be going up, all right? So if I'm making a quick sketch of this thing, I can draw in my end behaviors. I can come over here on the left-hand side, and I can draw the end of my polynomial. There it is, going down. And on the right-hand side, I can draw the end of my polynomial going up. So I've got the ends of my polynomial sketched. All right, and we are going to have to do this on the quiz tomorrow, where we create this quick sketch, we take a picture and we upload it to kind of show that we know what's going on with this information. All right, the next thing we want to do is we want to mark our zeros on the x-axis. So we have a 0 at -1. I'm going to go here, so -1, mark a point, +1, mark a point, 2, mark a point, and then -4 will be over here. And mark a point. All right. So now we know all of the locations where this polynomial is going to pass through the x-axis. All right. Now the last thing that we've got to take into account here, again, are these exponents, because these exponents are telling us that these are special kinds of roots, right? So anytime we see an exponent of 2, that indicates that this is a double root. Right, so that is a double root, and if we have an exponent of 3, that indicates a triple root. All right, and the reason that we care about that is simply because when we pass through double and triple roots, there's different behaviors that occur at those types of roots. All right, so let's go ahead and start drawing our polynomial here. We're going to start at the left end behavior, and we're going to come up to the -4. All right, and the -4 over here comes from this factor, x plus 4, which is an exponent of 3, so we know this is a triple root. And when we pass through a triple root, we do what's called an inflection. That means we come up, we flatten out, and then we continue back up, all right? So I have to see that inflection as you pass through any triple root. If I don't see that, then I can't assess whether or not you know what happens at a triple root, all right? Now, at some point in this polynomial, we have to turn back around and come back down towards the -1. Okay, so the -1 comes from this root, and that is a double root. And when we come to a double root, we bounce. All right, so we're going to touch the x-axis and then come back up. All right, rather than just passing through, we bounce off the x-axis. Now, again, I'm going to have to turn back around and come back down towards the +1. And that comes from this factor, which is also a double root. So we're going to bounce off of this one too. So we're going to bounce, boing. All right, and then we come back up, and then we have to turn back around because we have to come back down to the 2. The 2 comes from this factor, and so we're going to bounce off of that one too because it's also a double root. So we bounce again, and then we come back up and meet our other end behavior. So there is my quick sketch. Again, what I'm looking for the correct placement of the x-intercepts, the correct end behaviors, and the correct bouncing or inflecting at double and triple roots. Everything else I really don't care about. It does not have to be a work of art. It does not have to be to scale. It does not have to be super duper accurate, all right? It is a general sketch, and those are the things I'm looking for. All right. So then we got into the second part of the unit, and this is where we talked about complex numbers. So these are brand new numbers. You never knew about these before, but they do exist, and we have a complex number right here, the square root of -100. So we talked about this idea we cannot square root negatives, and real quickly, here's why. If I take the square root of -9, a lot of people might say, well, that could be -3. Problem is, -3 times -3 is a +9, not a -9. Even if you did +3 times +3, that's still a +9. So there is no combination of real numbers that you could square to get a -9. So a long time ago, right? Raphael Bombelli created the imaginary number. He said the square root of -1 equals I, all right? And this was a brand new number. So now when we see something like this, where we have a negative inside of the square root, we want to rewrite that number as -1 times 100, all right? And then I can split that square root apart. So I can say the square root of -1 times the square root of 100. And remember, the square root of -1 is I, so now we have I times, and the square root of -100 is 10, so we get 10I. Okay? There is our complex number. So we took square root of -100, and we expressed it as a complex number in terms of I. Okay? Here we go. All right, now, multiplying complex numbers, all right? We might run into a situation like this where we need to multiply two complex numbers. So with this one, right, you want to make sure you take the 7 and the 2 here. We can multiply that first, right? So 7 times -2 is -14. And then we can do the I times I, which will give us I squared. And we had talked about the powers of I, right? And I squared was one of the definitions we came up with. I squared is simply -1, right? So really, this 14I squared is the same thing as saying -14 times -1, which turns it into a +14. Okay? So we're going to see situations like that, and it's going to be important to take into account the powers of I. You don't want to leave your answer like this with a power of I that has not been simplified. All right. So let's do some more. So we got some more complex numbers here. We're going to do all the operations now. So adding, notice that we have parentheses around these things, and usually to get rid of parentheses, we would distribute whatever numbers on the outside. Well, if we don't see a number, we get to assume those are ones, right? So if we distribute a 1, nothing really changes in here, so the parentheses are actually unnecessary, right? And then over here, we'll have -3 plus 8i, okay? And I'm going to add those together, right? So we got -3 and -3. When we combine those, we get a -6. And then we have -8i and a +8i. So when I combine those, we get 0. Right? So this is our final answer, -6. Right? So here it's the same exact two complex numbers, but now we are subtracting. So again, you get to assume a 1 is on the outside. And we see over here, now this is a -1 that's being distributed. So on this one, if I distribute a 1, nothing changes. We get -3 minus 8i. But over here, If I distribute a negative 1, well, that turns that thing into a positive 3. And if I distribute a negative 1 to the 8i, then we get minus 8i. Okay. So let's see what happens here. We've got negative 3 and a positive 3, so those cancel out, right? That's just going to become 0. And then negative 8i minus another 8i, well, that's minus 16i. Okay. So there's our final answer on that one. So pretty easy, right? But this is a common mistake right here, this little piece. A lot of students forget to distribute the negative 1, all right? They'll just remove the parentheses and continue on, but you don't want to do that, all right? Make sure you distribute that negative 1 so you get the correct signs on the terms inside of that parentheses, all right? Now over here, we're multiplying. So remember, when you multiply two complex numbers that are like this, where they have two parts, you want to set up a box to help you out. Okay, so I'm going to set up my box, and it's going to be a 2 by 2 since each of those parentheses has two things. All right, so I'm going to put my negative 3 minus 8i here and a negative 3 plus 8i across the top, and then we'll just go through and multiply. This will be positive 9, negative 24i, positive 24i, and negative 64i squared. Common mistake there the students make. They forget that I times I is I squared. Now add up your four boxes. We get 9 plus 24i minus 24i minus 64i squared. So notice here, positive 24, negative 24i, those are going to cancel. So now we've got 9 minus 64i squared. I squared is just negative 1, so we get 9 minus 64 times negative 1. So this is going to end up being 9 plus 64, which is 73. So be careful with the negatives. That is the biggest thing that tends to trip up students on these types of problems. All right, let's keep going. All right, so we've got a polynomial. They want us to write a polynomial. Notice that standard form is bolded and underlined here. All right, so write a polynomial function in standard form that has these two roots. Okay, not a problem. All right, so in standard form, let's start with factored form first, right? Factored form is really easy to write. It's going to look like this. I have two roots, so I'm going to have two linear factors. So if I have a factor of 5i, that means if I have a root of 5i, then I will have a factor of x minus 5i. And then same thing for the other one, I'll get x plus 5i. All right, now to get this thing in a standard form, we just need to multiply. Okay, so I'm going to set up a box, and I'm going to multiply those two factors that I just created. Okay, so we've got x minus 5i, x plus 5i, and then we're going to multiply. So we got x squared, 5ix. I know that's weird, but there's nothing we can really do with that. It's just 5 times I times x. There's no simplifying to be done there. So we're going to get the same thing down here, negative 5ix, and then negative 25i squared. So just like in that previous problem, we're going to take our four boxes and we are going to add them together. All right, so we got x squared plus 5ix minus 5ix minus 25i squared. All right, so notice here, these are like terms. Since they both have an I, they both have an x. One's positive, one's negative. So these are going to cancel out, right? 5 and negative 5, those are going to add to become 0. So we get x squared minus 25i squared. Don't forget about your powers of I. I squared is negative 1, so we get x squared minus 25 times negative 1. So this is going to turn into x squared plus 25. And that is my standard form. Okay, so this is what they're looking for. Don't do this, right? This is factored form. This is a good start. You're going to want to do this so that you can set this stuff up, all right? All right, last problem I'm going to show today. This is the last part of chapter 8. This is what we focused on when we got to taking a higher order polynomial and factoring it and finding all of its roots. Okay, so we have a third degree polynomial. Our goal is to get to something that looks like this, right? We want our three factors here, and we want to know all of its roots. All right, so the the first step here is just to look at the graph. And I've already got this thing plugged into Desmos, so let's see what we've got. Got it plugged in right here and turn on the graph. And we are looking for our roots, and roots can be found at the x-intercepts on the graph. So we're looking for where this thing crosses the x-axis, and I see a location right here at 5, 0. Okay. So the root that I found is 5, which means I have a factor of x minus 5. Okay. So one of my factors here is x minus 5. I need to find my other two factors, and I need to find my other two roots. Okay, so to do that, I'm going to take my original polynomial. I'm going to take x to the third minus 5x squared plus x minus 5, and I'm going to divide it by this supposed factor. Okay, so I think x minus 5 might be a factor. And when I do this division, I'm gonna accomplish two things. One, I'm gonna verify that this is actually a factor. If I divide this and there's no remainder at the end, then I know that x minus 5 is a factor. And at the same time, whatever is left over after I divide will be the polynomial that contains my other two roots. So I'll create that other polynomial and be able to find the other two roots from it. Okay, so watch what happens here. All right, I'm going to set up my division. We got x minus 5, and then down here along the bottom, I've got my x cubed minus 5x squared plus x minus 5. Okay. And we start our Paladoku. We know the x to the third goes in that upper left-hand box. So we're going to get an x squared up here, right? Because x squared times x is x cubed. And then I'm going to multiply down. So we get negative 5x squared here. And remember the trick with the diagonals. This first diagonal here, that's where our x squareds go. We need negative 5x squareds. We already have negative 5x squareds. So we don't want any more, right? Or any less. So we're going to say 0. And we're just going to put a 0 there. So something times x gives me 0. Well, that's got to be 0. And then I multiply down. 0 times negative 5 is 0. Next diagonal. All right, so this diagonal, this is where our x's are located. All right, and I need 1x. So I currently have 0, so I'm gonna put my 1x up here in this box. So that way 1x plus 0 is x. And then we're gonna need a 1 up here because 1 times x is 1x. And then we multiply down, so 1 times negative 5 is negative 5. Now remember what I talked about with the remainder. Notice that the number in our right-hand box here, that last number, matches up with the end of our polynomial. So it divided into it evenly. That confirms this thing is a factor, and it also confirms that this is a root. All right. Now that I divided, what's left over is this x squared plus 1. All right, so we have x minus 5, and then the other polynomial is x squared plus 1. This is the polynomial that contains my other two roots. So I can use this to find my two missing roots that I don't have yet. All right, so let's go. Let's find that thing. You can either extract roots or use a quadratic formula. I'm going to go with the extracting roots. So I'm going to take x squared plus 1, and I'm going to set it equal to 0. And I showed this in yesterday's video. This could be a lot quicker than doing the quadratic formula. I personally think it is, but if you want to use the quadratic formula, go ahead. I'm going to subtract 1. Right, just get x by itself. So I got x squared equals negative 1, and then we square root both sides. That way the square and the square root cancel, so we get x equals the square root of negative 1, and we know the square root of negative 1 is just I. All right, so we're going to get plus or minus I. Remember, complex zeros always happen in conjugate pairs. Also, when we square root things, we get two answers. Technically, so that's where our two roots come from, right? So we solve this equation, but we know that we get a positive and a negative version of I. All right, so if I'm listing all of my roots, I found two more roots, right? So the roots that I found 5, I, and negative I. There's my three roots. So if I want to write this thing in its factored form, I can say, well, I have x minus 5 because I have a root of 5 here, and then I'm going to have x minus I, and then another factor of x plus I. So there's my roots, there's my factored form. All right, guys, that's it for today's review. Hopefully you found that helpful. If you have any questions, please let me know in the Zoom chat. Good luck on your quiz tomorrow.